Hi everyone, welcome back. Lastly we learned about k-means and today we are gonna learn about partition function. This function is also very important. This is gonna help us to distinguish the colors or the features inside the image. This is a very important function, I can say, and the usage maybe we can talk about in the code part more clearly. Basically we are just giving the input and the labels, the data we are giving, and it's gonna give us the output vector of the labels, which is gonna represent the each pixel belongs to which class, which labels it belongs to, and also we need to give as input the class differentiation, how it's gonna differentiate the features or the colors inside the image. So for this function I want to use a very good example, which I think I like in this one, the Barak in this forum. He already suggested a function in here, so I'm planning to use this one because it's very useful. Also I already copied two kind of images. I want to differentiate this image and this one, so we can see how it's distinguish the colors and it's giving us the output accordingly. Okay, I just wanted to copy this differentiation function, which is this one. So basically it's just also maybe I need to give this namespace of the CV. Normally I don't like, but for just saving time for this video we can give temporarily. Okay, basically this function is just taking two pixel values and is comparing between how they are different than each other with the norm function of the OpenCV, and it's just comparing two pixel values, and if it is smaller than 65, this is, as the Alekin write, this experimental value. So you can, if you want to more precise the differentiate, you can decrease this value. So 65 for this image is enough, he said, and it just compares two pixel values and returning the bool value. They are different than each other, or they are almost same to each other according to this experimental value. Okay, this is our differentiation struct function, we can say, and the other one we need to copy here, and all is gonna be enough. So let me copy this one in here. Maybe I can put the image path also to here. Okay, so basically we are just reading the image. It's resizing because for two combination of the thousands of pixels it's gonna take long time, so it's also wrote here I'm in a hurry. So even we try to run for all the pixels inside this image, or approximately, I don't know the size, but it's huge value, so it's better to resize for just example. But in your case you can use the direct image, but as I said, according to the size of the image it's gonna take really long time. Okay, also I want to see an output, so I'm gonna create a name window because or we write out, since this is gonna be small image because of the resize, I want to use the name window normal, so it's gonna help us to visualize more bigger window. Okay, and the data we need to give the input to the partition function, so we are just inserting this met type into this vector float type of the data. So we are, because this is taking in that kind of input, so we are just converting met data type into the vector, so we are giving, and it's gonna give us the labels accordingly. So data size is equal to label size, so label size is gonna represent for all the pixels inside the image. We are gonna understand more clearly later. And we are giving the differentiation function, so it's gonna give us the, first of all, the return type of this function is gonna return the number of the classes or clusters is gonna return. So also the labels we need to use at the end and nothing else. The other input we are just giving, and I need to im show, and this is gonna be out, and it's gonna show the met type of m, and we need to call wait key. Okay, and now we can run the code. So approximately for the deal of the 12,000 pixels we are dealing with, so even maybe I want to decrease this because even this resize is taking really long time. Let's see first of all the first output, and 65 is giving. So I'm expecting how many cluster inside the image. Maybe after it's almost done we can check. Okay, so 6 clusters is saying. Normally you see 5 shape, but the background also is a cluster, so this black color is also representing as class or as cluster. So 1 the background, 2, 3, 4, 5 and 6 clusters. So the experimental value, the Alekin tried, is correct. And I want to decrease this value because it's taking really long time, so it's gonna deal with less pixel values now for, okay, again giving the same cluster, so there is no problem. As I said, this is a huge function, I can say. For time cost, you need to be careful if you really want to use this function. You see, even 3000 pixels is taking a couple of seconds. Okay, and this is done. Now I want to see what this labels is representing at the output. K we already see, so it's representing the cluster numbers, and I want to check for the labels, so I need a for loop, and it's gonna deal with all labels dot size, and okay, this is size t, don't complain. And okay, so now maybe for just showing, I can show the label size so we can be sure it is also same size with the 3072 pixels. So I'm expecting the label numbers also same as the pixel numbers, so I'm expecting to see the same label numbers, you see, because for each pixel I need a cluster. And now I need to check these labels for just an example. Maybe this is the background is a black image, so maybe I need to make white. So if the labels, since these are gonna be integer, the labels 0 is equal to labels I, labels I is equal to 0, which is the 0th cluster, then I want the this m dot add and cv vector 3b, since this is a colored image, and point, here we need to make a logic. This logic is gonna be the point, the first one is gonna be the, since this is a vector, we need to think in the 2D. So these are coming in 1D, we need to convert in some way, or we need to, because we need to give x and the y coordinates into the here. So we need to think this 1D as 2D. And how we are gonna do that? All we need to do is just this I mod, the first one is gonna be representing the column number, so this is gonna be the mod, and m dot columns is gonna be enough, and the second is gonna be just dividing m dot columns again, and so this is the row number and this is the column number. So this is, I think, is correct. So we are just equalizing to the vector 3b again, and I want to make this as, since the background is the black, I want to make this white color, and I think this is enough. So at the output now I'm expecting the 0th class, the one of the features inside the image, one of the colors is gonna be totally white, so we can see which is the 0th cluster. Okay, so the 0th one is the background, as you can see, before here was black, so the 0th cluster is becoming white because we changed the color as white, so we can understand this is the 0th color. So for the similar case, we can make for the 1, and now which one white? This one. So this rectangle is becoming white, so this is my first cluster, and let's make 3, which is the third one. So now this one is the third, so it's continue accordingly. I don't want to try for all. Yes, so easily you are differentiating the colors, shapes inside the simple image, and it's also giving you the output of the labels. This is the first example I want to try, and also I copied a different image from internet again. This one, let's try ff.png. Just change the name. I think 65 is not gonna be enough for this maybe. So this found just two clusters, which is I think this and all the background. So it's ignored this one. So what we need to do is just changing this threshold value. Also I want to change the color because this image color is background is white, so I want to make the font cluster is black so we can easily understand. So let's change this into the 40. So how many cluster is gonna find? Now it found 2. I have more 8. Sorry, by the way, this is the correct image. Okay, this is the correct image. So now it found 8 cluster, but I have 3, 4, 5. I have 6 clusters. So let's increase the value a little bit and see, or we should decrease, sorry, 35. Let's make 11. Maybe this image, the pixel values is really less, so I want to little increase the resolution because the size is make it really small. Okay, now it finds 6 clusters at least, maybe 4. Yeah, actually it also has 6 clusters. These two is similar. Maybe it's a little confused, but just this for example, and most is finds correct. Okay, let's see the zeroth one. The zeroth is, I think, again is gonna be the background. So this is white normally, so it's becoming black. So this is ignored. This shape also ignored because of the threshold. Well, I don't want to deal more. But the first one is this one. Let's try the second one, second cluster. So now it's gonna be the black color. Okay, the circle now becoming my second cluster. Let's try for the, let's say, fourth one, and the fourth one is gonna be, let's say, rectangle. Yeah. So this function you can easily understand anymore. It's just making differentiation of the image according to the input function you are giving. We are just making a simple one. You can make more complicated function according to your filter. And yeah, so we also tried this Alekin. I think this is Alekin, this Barak, and making a good example. And we tried this one, and we are now understanding what this partition actually doing. Okay, thanks for watching. See you in the next videos.